Moving forward now into radical expressions and functions. We'll need to recall that perfect squares are numbers that are created by multiplying a particular value times itself. Since a perfect square is a value that results from a number multiplied times itself, then the numbers such as 4, 9, 16, 25, 36, and 49 are all considered perfect squares. Notice that those numbers were created by multiplying the same number times itself in order to result in that number. So 4 was created by multiplying 2 times 2, 9 was created by multiplying 3 times 3, 16 was created by multiplying 4 times 4, 25 by multiplying 5 times 5. We shorten that by using an exponent, which you've learned looks like this. 6 squared equals 36, 7 squared equals 49, and so on. I could continue on with 8 squared, 9 squared, 10 squared, and continue on. Each time we have the result of a number squared, we get a perfect square. So that leads us to a radical. The radical sign is the operation that we use to reverse a perfect square. So when we square a number, we also want to be able to undo that. If we want to reverse the squaring of a number, then we take the radical sign and we take its square root. We find the root. So when we want to reverse, we use the radical sign and we find the root. This is the symbolism that you will see when we're taking the root and using the radical symbol to undo the squaring of a number. The index is this number right here, and that tells us what root we're looking for. Generally, if we're taking the square root, trying to figure out what number times itself just one time, we don't write the 2. You won't see a number there, but if it's a cube root or a fourth root or a fifth root, anything above a 2, then you'll have a number there. The radicand is the number that is underneath of the radical sign, and the radical is just the big check mark. And then the whole thing is referred to as the radical expression. Now what about negatives when we talk about radicals? When you see a negative with a radical, you're going to see it in two different situations. You're going to see it where it is sitting on the outside of the radical, and you're going to see it where it's on the inside. So let's look at it when it's on the outside first. When it's on the outside, it's like multiplying by a negative 1. So in this case, if I am taking the square root of 25, in other words, if I'm looking for the number that was multiplied times itself in order to get 25, and I have a negative sign on the outside, then I'm saying find that value and then take its opposite, or multiply it times a negative 1. So I'm taking the square root of 25 and I'm multiplying it times a negative 1. So I knew that 5 squared equals 25. So to take the square root of 25, I said I knew that 5 squared was 25. So when I took the square root of 25, then I multiplied it times negative 1, my answer is going to be negative 5. So that's one case of the negative. Another case of the negative is when the negative's underneath the radical sign. And that is not the same as having the negative on the outside of the negative, or of the radical sign. The reason it is not the same is because we cannot take the square root of a negative number. Remember when we talked about perfect squares? When we talked about perfect squares, we were multiplying the same number times itself in order to result in this perfect number right here. Well, if I was going to try to take the square root of a negative 25. That would mean that I had multiplied the same number times itself and gotten a negative result. In no instance can I multiply two negative values together and get a negative result. So I cannot have a negative result underneath of this radical sign. It's impossible to have a negative result. So this is why I cannot take a negative square root. So this is not something that can be done. Later on, we're going to learn about something called imaginary numbers. For now, we're just going to say there is no real solution to that. So let's talk about evaluating a square root. When we say to evaluate a square root, that means to determine which two numbers multiply to equal the radicand. Once the square root is evaluated, we remove the radical sign. So evaluating the square root essentially means we're taking that square root. We're doing that operation. So let's evaluate the square root of 16. I'm asking myself, what number multiplied times itself equals 16? Well, I have two options here. 4 times 4 equals 16. But I have another option. Negative 4 times negative 4 also equals 16. So my answer here is not just 4. It's actually positive and negative 4. So the square root of 16 is positive and negative 4. Let's take a look at the fraction negative 9 over 16. And remember, what did we say it was when there was a negative on the outside? It's like multiplying times a negative 1 when I'm all done. 9 is a perfect square, and so is 16. So when you see a fraction, you can take the square root of the numerator and the denominator. So the square root of 9 is 3, and the square root of 16 is 4. I multiply the result by negative 1, and I get a negative 3 over 4. How about the square root of negative 36? Did you first try to say 6? That's not correct. We cannot take the square root of a negative number. If I try to say 6, 6 times 6 equals a positive 36. Negative 6 times negative 6 also equals a positive 36. I can't say negative 6 times positive 6 because that's not multiplying the same number times itself. Those are two different numbers. So I can't take the square root of a negative number. There's no real solution to that. So let's try the next one. The square root of 144 plus the square root of 25. The square root of 144 is 12. The square root of 25 is 5. So 12 plus 5 equals 17. Not so bad, right? In addition to square roots, we're also going to talk about perfect cubes. Not only can we multiply a number times itself 2 times, we can multiply a number times itself 3 times. And when we do that, we get what are called perfect cubes. So 2 times 2 times 2 gives us 8, 3 times 3 times 3, 27, 4 times 4 times 4, 64, and 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, and so on. So remember, we don't really want to write it all out like this. We would use exponents instead and shorten the multiplication. And just like with square roots, we can take cube roots. And just like with taking a square root, finding a cube root reverses the process of cubing a number. So a square root reverses the process of squaring a number, and a cube root reverses the process of cubing a number. Now, remember I told you that on a square root, the index won't always be written because it's just an understood 2. This is not the case when we have a cube root. When you have a cube root, the index will always be written and it'll always be a 3. If it's a fourth root, it'll always be written and it'll always be a 4. So if I want you to take the cube root of 64, it will always be written as the cube root of 64. And you'll see a 3 right there. That will be your cue to look for the number that is multiplied times itself 3 times in order to equal 64. So the cube root of 64 is 4, because 4 times 4 times 4 equals 64. Now what about negatives? Well, when we're talking about cube roots, we can take the cube root of a negative number. Why is that? Well, unlike square roots, when we multiply two negatives together, we ended up with a positive. But since we have this extra number out here, when we multiply again times that negative, we turn the answer negative again. So we can take the cube root of a negative number because we have this extra number to turn our result negative. So it works out that we can take the cube root of a negative number. So let's show examples of cube roots. We've already talked about the cube root of 64, but let's look at it again. The cube root of 64 is 4, because 4 cubed is 64. The cube root of negative 64 is negative 4. Is negative 4 times negative 4 times negative 4 will equal negative 64. Notice how I drop the radical sign after I take the cube root. The cube root of 216 is 6, because 6 cubed equals 216. It may be handy to keep a chart of perfect cubes and perfect squares and perfect fourths. Now, using the calculator, since you may not have all these perfect squares, perfect cubes, and perfect fourths memorized, every calculator has a root function built in, but not all calculators have the keys labeled the same. Find that key on your calculator that performs the operation of taking a root, either a square root, a cube root, a fourth root, a fifth root, or so on. If you're not sure which key it is, go to Google. Type in your calculator model number and make, is it Texas Instrument, Casio, whatever, and then type the words square root function or cube root function or whatever, just some combination of those words, and you'll be surprised what comes up. You'll find images, complete instructions, everything you need to find the keys that make it happen for you on your calculator. Here are a few examples of what you might be looking for. Generally, it's attached to the square root key, or the exponent key. It's usually the second function above the exponent key. On this calculator, it has the square root key is there, and then this key lets you enter in any root key that you want. You can enter in cube root, fourth root, fifth root. The y can be changed to any value. On this calculator, they give you cube root and square root. I believe right here they're going to let you enter in any root you want. Now I don't know what your calculator looks like. It may not look like any one of these three, but again, you can Google yours, or maybe you already know what it looks like. So make sure you find the root key on your calculator. It will come in very, very handy as you work with roots and radicals.